So when we carry on into 3.1, we're looking at how can we tell how many x-intercepts something has without drawing it. This is a way of checking to see if you solve for those x-intercepts, those hard ones to solve for, right? If you've solved the right thing, because sometimes you have no x-intercepts, and sometimes you have 2, and sometimes you have 1. I left them to think, so you should pause the video and think, how does that work? And I told them to look at A and K, right? That's basically my hints. So when they looked at the A's and the K's, the first thing they said is they talked about this middle one, the one with the 1 x-intercept, right? You guys are talking here. Ooh. What did you notice? K equaled, well, they just said K's not there. That's basically what you guys said. But what does K equal when you have 1 in? K equals 0. So that means your vertex is on the y value of 0. And where is the y value of 0? Along this line, right? That's where y equals 0. So if it's hitting y equals 0, then you'll have 1 x-intercept because your vertex is the only point that's going to hit on it. It's either going to go up or it's going to go down, right? So that's great for that first one, or I guess the middle. What do you notice about the 2 x-intercepts or the no x-intercepts? Well, the K's aren't 0, that's for sure. My A values here can be positive or negative. My A values here can be positive or negative. What makes it different? When the A is positive here, what's my K value? What does positive A mean? Positive A means concave up, right? So if positive A means concave up, and your vertex belongs in the negative K, that's a negative Y. So if my vertex is in a negative Y zone down here or here or here, if it's concave up, it's always going to cross the x-axis, right? What happens when A is negative? What's the K value in these 2 x-intercepts? Positive. So if it is positive, my K value, sorry, I'll try again. If my vertex is up here somewhere and it's concave down because of the negative A value, you're always going to end up with 2 x-intercepts, okay? So basically, the A's and the K's are the opposite values, causing 2 x-intercepts. And K cannot equal what? 0. Go over and look at that last column then. No x-intercepts. What do you notice? If A is positive, K is positive. If A is negative, K is negative. K doesn't equal 0. K is where the Y value is, right? So let's take a look at that. So if the vertex is in the positive and your A is positive, what does that mean? It's concave up, right? If it's concave up and your vertex is already in the positive Y, does it ever cross the x-axis? No, and that's why we get no x-intercepts. So now we can look at our questions and see, oh, I'm going to be able to solve for 2. Oh, I'm going to be able to solve for 1. I don't even need to try and solve for this guy because there's no x-intercepts because my A is positive and my K is positive. Okay? That's helpful, right? How many y-intercepts will a quadratic function have? Only one. Now why? Whenever we draw a vertex, or the parabola goes outwards in both ways. No matter where you're going to draw them, they're always going to cross the y-axis once, whether there's one x-intercept, two x-intercepts, or zero x-intercepts. They're always going to cross the y-axis once. So you're always going to have one y-intercept at all times. So we're going to look at a different way of graphing today, okay? We're going to look at a way of graphing that is slightly different, that we actually will use this kind of translation graphing in your pre-calc 30. So don't just go, oh, I know how to do it one way, right? You're going to use this way next year in pre-calc 30 if you carry along with me. So you might as well take a look at it now, right? See if you can't grab that concept and be happy. Okay? So the first thing we're going to do is we're going to look at just the plane y equals x squared. So y equals x squared, how many x-intercepts? What's your k value? 0. So how many? 1. You're going to end up with 1. The vertex is going to fall on that, right? We just know that already. So we're going to have 1 x-intercept. Now, if we plug in with the table of values, remember we try and go right around the vertex. If we look at x squared, your h was 0, no, your k was 0, but your h is also 0, so your vertex is right at 0, 0, right? So you can plug in 0, 0 squared is 0, then we'll go 1, 1 squared is 1, 2, 2 squared is 4, negative 1 squared. Remember when you put that into your calculator, it's brackets negative 1 squared, it's brackets negative 2 squared, right? Because that negative is part of that number, you have to include it as part of that number. So if we want to graph it, we can graph the regular x squared, that's 0 and 0, then 1 and 1, then 2 and 4. So this is just a regular y equals x squared one in black. Okay. Now, I want you to graph x plus 2 squared minus 4. Okay. So what this does is it shifts it. Okay. So step 1, horizontal translation. A horizontal translation is a fancy way of moving horizontally, okay? A vertical translation is a fancy way of moving it up and down, okay? Your h and your k were not only your vertex, they're actually your translations. So it's saying that you're shifting so many horizontally and you're shifting so many vertically. Now, horizontally, our x value, it says positive 2, but what do we have to remember? We have to bring it out as a minus 2, right? When we bring it out. So our x, we're shifting it minus 2, And our y value, we are, because it says minus 4 here, we're going to shift our y value minus 4. So you'll notice I'm kind of creating a secondary table of values, right? But my secondary table of values says x minus 2, y minus 4. So what I can do here is I can take the x values and subtract 2 off of them. So minus 2 is minus 4, minus 1 minus 2 is minus 3, 0 minus 2 is minus 2, 1 minus 2 is negative 1, 2 minus 2 is 0. Okay, so I just took the x values from my original one and followed through and subtracted 2. This helps me find all the points for graphing. So then I don't have to go and do the vertex, find the x, because that was long and annoying at times, right? Finding the vertex, finding the y-intercept, the x-intercept. If we can just do these shifts and just subtract 2 and subtract 4, or add 1 and add 3, if we can do this, it makes life even easier than finding those x-intercepts and remembering to do plus or minus at square root, right? It does. So this last one, 4 minus 4 is 0, 1 minus 4, negative 3, 0 minus 4, negative 4, 1 minus 4, negative 3, 4 minus 4, 0. I now have 5 points without a lot of math. I subtracted 2 and I subtracted 4, right? The hardest part is I have to remember the original numbers x and y for y equals x squared. Okay? So then I can graph this by going negative 4 comma 0. So negative 4 is an x value, so I actually need to be over here. Negative 4 comma 0 is right here. Negative 3 comma negative 3, right here. Negative 2 comma negative 4, negative 1 comma negative 3, and 0 comma 0. And I can draw my new graph. Okay. So far so good. If I took this new graph and I shifted it right back 2, so forward 2, 1, 2, and up 4, 1, 2, 3, 4. You'll notice, now I'm not a perfect graph maker, but it's the original y equals x squared, right? And I've shifted down 4, right, because that was our vertical translation, 1, 2, 3, 4, and over 2, 1, 2, negative 2. What happens? I get the new graph, okay? Shifting it down and over. So some people will draw this one and then just go 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2, and they'll keep on hitting those points, 1, 2, 3, 4, over 2, 1, 2, 3, 4. So they'll draw the original one and then just move 4 and over 2 instead of drawing that table of values. Okay? Multiple different ways of looking at it. So, oh look, we just did step 3 and 4 and 5 all together at once without that graph paper. Did we not? Sorry, I'm really bad at paying attention. So basically, we did absolutely all the steps to graph it. So let's try the same thing, but I'm adding in an A. Okay? Is that okay? Sorry, we just skipped a page and a half or something like that, or half a page. or at the bottom of the second page. No, we're on now. Try this method with this one. And we could probably graph right above, right, if you wanted to. We did step 3 and 4 and 5 all together. But we're still on the second page in the bottom corner. So, can someone tell me the horizontal shift on our new question? +3. I agree with you, Kara. A horizontal shift is the X shift, okay? And that's probably even why they label it H. H standing for horizontal shift, right? Don't ask me why they label the next one K, though, because that's not vertical. But we could think of H as a horizontal shift, so it's a +3. Because when we take it out of the brackets, we get a +3. And we have a vertical shift of -1. Now, I need to tell you, what does this 2 do? What does the A value do? Do you guys remember what it does when we graphed it before in Math Foundations? In Math Foundations, what happened was when we were graphing it, that's just a regular x squared, then a 2x squared. It actually just shoots it, makes it skinnier, it stretches the parabola faster. Okay? What does it really change? Your amplitude, if you put a single x value in, it's going to take the y value that originally was there and times it by 2. So it's actually going to do, it's going to change your y value by that amount. So it's going to double it in this case. So your y value is going to double. So how are we going to graph it instead of using the vertex graphing form and finding the vertex and finding the x-intercept, finding the y-intercept? Okay? So I'm going to show you all the steps and how I would do it. I just have to remember this equation, or you're going to have to tell me this equation. So we're going to go to this next page right here. The first thing I'm going to do is, hopefully you have room, I'm going to do a little table here, and I'm going to do an XY table of just y equals x squared. Do you guys remember that one? That's going to be called, it's like our, okay, it's called the mother function, okay? Is a function that's based off of everything else. So it's the main function. They call it the mother function. Okay? So what do we have to remember? Where's the vertex of this function? 0, 0, right? And then if we had -1, +1, 2, and -2. -2 squared is 4. -1 squared is 1, 1, and 4. I have to remember that this is the basic function for quadratic equations, okay? Y equals x squared. And I can use this basic function and its basic table of values to move the horizontal vertical shifts as well as the A value, right? The A value is its stretch. So, what was our original question, or the question we're dealing with? Sorry. The question we're dealing is y is equal to 2 bracket x minus 3 squared minus 1. So in my x value, we're adding 3, right? Because the horizontal shift is +3. But in the y value, We're subtracting 1, but then we have this amplitude, right? That 2. It actually doubles the y value before you subtract 1, right? So we write 2y minus 1 in there.
How come it goes in the y?
Because it changes the y value. Because when we actually go to import it, if we put a number in for x in this question, like if I put 1 in here, it's not going to change the x value. It's actually going to change the y value. If this wasn't there, the y value would be twice as small. Well, almost twice as small. But because we have the 2 in, we go 2 times this, and then we subtract the 1. So it affects the y value. That's why we put it on the y. If it affected the x, then we would put it on the x. How would it affect the x? If the question was written in this kind of manner, it's right on the x, right beside the x, it might just affect the x value. But we're not worried about that yet because we never had questions written like that or anything like that. So we're going to avoid that until later on. Okay, so now what do I do? What would be my next step? Step 3 or 4 here. Minus 2 plus 3 is 1. Minus 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. Okay, so we got all the x's. Then we have to deal with this equation, 2y minus 1. So I go 2 times 4 is 8. 8 minus 1 is 7. 1 times 2 is 2 minus 1 is 1. 0 times 2, 0 minus 1 is negative 1. 1 times 2 is 2, minus 1 is 1. What you'll notice is that once you get to the second half, it just reiterates itself here. So like if I take 4, 4 times 2 is 8, minus 1 gives me 7. So it's kind of like it copies itself back over. Okay. So now that you have that, we don't even have to graph this original function if we don't want. We just have to graph that function, the new function with all the shifts. So the way we do it is we just plug in the points. So 1 comma 7, 1 comma 7, 2 comma 1, 3 comma negative 1, 4 comma 1, and 5 comma 7. And, I should erase that. You should really try and hit, these lines. Okay, and hit those points. If you don't hit those points, you should erase and try again. And really try to hit at the crosshairs. Okay? So that's the new parabola. How would we go about and graph it the old school way? Do you want me to quickly run through that? No? Because take a look here. Your x-intercepts are going to be those ones that we were complaining about, those root 6 plus 1s and negative root 6 plus 1s and stuff like that, because they don't actually hit a nice number, right? So those are harder to graph. But all these ones are nice whole numbers for you to graph. You don't have any root 4 plus 3s or root 7 plus 2s. Okay? So this makes it nice and easy. So the next thing that we're going to do, why is it freaking out on me? Sorry, it's freaking out at me. Okay, where? Okay, so it stopped freaking out on me. So it says write an equation, right? That's the next kind of step. It's at the bottom of your third page, or the bottom of your front of your second page, I guess it would be. Third printed page. So it says write the equation of a parabola that has a vertex and passes through point. Okay? So we looked at a different way of graphing. Now we're looking at, okay, what if they only give us 2 points, one being the vertex and one being a different point on the graph? I remember showing you guys how to do this. The big thing is when we're filling out this vertex graphing form, we have an H and a K, we have an X and a Y, those are both points, and we have an A value. When you write the vertex graphing form, you always leave the X and the Y alone, and you fill out the H and the K and the A. Sorry, the H and the K and the A. Well, we don't have the A value, but we have an X and a Y. So the first step is basically fill in your H and your K, your vertex. So in step 1, we get Y is equal to A bracket X. Now, plus 3, thank you, squared plus 7, right? Fill in your H and your K. Your H should be an opposite sign than what was in the actual vertex. Your K should be the same side as it was in your vertex. Now, we want to fill out that A, but we don't have that A value, right? So we need to put in our other XY. So our other XY is 1, 2. So what would I put here for Y? 2. So this is in step 2. We're going to place X and Y. 2 is equal to A bracket 1 plus 3 squared plus 7. We're putting it into the brackets, and people get confused on this all the time. But when we insert x's no matter where, we always insert that value for 1. The reason why the sign changes is actually in this equation up here for the h. You'll notice it says x minus h in the equation. So if we put a minus 3 in, it says minus a minus 3. So a minus 3 turns it into a positive 3. But in front of the x, there's no negative sign. So we just keep it as the same sign. Okay? So we've got to carry on in here. Sorry, there was more space, but I pressed enter a couple extra times, or backspace. So step 3 is here. You guys have more space for step 2, I believe, right? So we need to solve for A. Now A is not alone, so remember we have to start moving things to the other side sometimes, and that might mean we have to, our first step, subtract the 7. So we get negative 5 is equal to A, but then I can do 1 plus 3 squared, right? 1 plus 3 is 4, and 4 squared is 16. How do I get A alone? I've got A times 16. Divide by 16. Okay? So now I have an A value of negative 5/16. Right? So the entire question says, write the equation of the parabola. Okay. So what's the equation of the parabola? This is step 3. This is the end. Putting it all together. Okay. So it's not going to be nice to me. I'm just going to write it above here. This is going to be where step 3 goes. I'm going to write it up here. We go back to the original formula that we had the vertex in, but we didn't have the a value. We write y is equal to, but now we have the a value, right? This should go right on step 3. Our a value is negative 5/16, and then we come back in, and we don't want to put a value in for x, so we go x plus 3 n bracket squared plus 7. So that will be your answer to the graph. So the big thing is sometimes you have to solve when they give you the vertex and one other point. You need to make an equation out of it. Okay? So let's look at a word problem. Okay? And then we're done. It's just the word problem, and then we're done. Okay. This will probably take the rest of the class, and then we'll work on some questions tomorrow, and then we'll carry on into 5.2. So we've got a football. It's thrown and reaches a maximum height of 25 feet. What's the key word in there so far? Maximum. That means that 25 feet, that's what? That's a height, that's a y value, h comma k. That's k then. Right? Maximum height of 25 feet after reaching a horizontal distance of 35. That's h. What is the equation of the path of the ball? Okay. Well, right now we know we can write y is equal to a bracket x minus 35 squared plus 25. But we need to solve for an a value. But we don't have any other point. Okay? Normally they might say the thrower is 6 feet tall or something, so then you could go 6 feet. That would be a height, so it would be 0, 6 feet. But if they don't tell you the height of that player, a lot of times you can assume that it starts at 0, 0 as another point. So we're starting at a 0 distance away, but the ball is thrown from a 0 height. Now, that's kind of an off kind of assumption, right? Because 0 height would mean you're throwing it from the ground, and no football player leans down and throws it upwards like that. They usually throw at a certain height above the ground, okay? So it would be nice if they told us the height of the football player, but if they don't, we make this assumption that it's 0, 0. Sometimes we talk about a platform and the divers jumping off the platform. Then, in that case, the platform's 10 feet high, you'd have an initial point of 0, 10 or something like that. Okay? But if they don't give you any of that information, we make the general 0, 0, and then we can come in and solve for an a value. So the first thing we would do is plug 0, 0 in, then subtract our 25, so we get negative 25 is equal to a times negative 35 squared. Does anyone know what 35 squared is? Or negative 35 squared is? 1225. Is that 35 squared? Okay. No, because a negative times a negative is a positive. So when we take the square of a negative, we still end up with a positive number. So we divide by 1225. I'm assuming we can reduce that fraction. So a is equal to negative 4 times 12 is 48 plus 1 is 49. So negative 49, negative 1 over 49. Right? Is our a value? So what would we write as the question? No, you need the 1 because we are reducing the negative 25 over 125, so you need the fraction of negative 1/49, right? because 25 goes into 25 once, 25 goes into 125 49 times. So we need the 149ths. So the equation turns out to be, and I'm just going to put it way up top here, y is equal to negative 149ths bracket x minus 35 squared plus 25. So that is the equation of the ball. So let's go. How would you solve this next question? How high is the ball when it has traveled 70 meters down the field? We have to solve for y, and x is 70. So we go in here, we get y is equal to negative 149ths. 70 minus 35 squared plus 25. So we get y is equal to negative 149ths times 35 squared plus 25. We could plug this entire thing into our equation because it's all on the same side, right? So negative 1 divided by 49 times 35 squared plus 25 gives us an answer of... I put the 70 right in here. 70 minus 35 is 35. What did we get? Yeah! Okay. Now, can I talk about this? If we're saying it's leaving from 0, 0, 35 down the field, right? And 25 high, that's the vertex, right? This is your vertex. Remember, it's a parabola form, right? So if it's 35 here to get up to 25, it's 35 over here to get back down to 0, right? 35 times 2 is 70, right? It's telling us it's double the vertex away, right? So it's kind of giving that hint. Some people could do this. Just think about it. Okay, 35, if it's going 0 to 35, then 35 to 70, it's going the same horizontal distance. So then it would be the same vertical as the first point that I did, which is 0. Okay? So let's look at C then. It says, how far has the ball traveled when it's at a height of 15? What would you do there? When it's at a height of 15, how far has the ball traveled? What would you do? That's our y. So we plug 15 in for y. This is when we're starting tomorrow. Then I think we'll have all day tomorrow to work on the questions. I'll assign you the questions and we'll finish 5.1. And then Wednesday we'll start 5.2.